Hello everyone, in this video we're going to talk about Cartesian vectors. Cartesian is a coordinate system with 2 or 3 axes depending on whether we are talking about 2D or 3D. So Cartesian coordinate system is very popular because the axes are perpendicular to one another. So it's very easy to find the component of each vector, x and y. Let's say we have a force F, and the force F makes an angle theta with x-axis. So I can represent this vector in Cartesian form based on its component in x and y direction. That would be fx. And here would be fy. So I can write fx I, which would be unit vector in the direction of x, and fy would be the unit vector in the direction of y, and j would be the unit vector in direction of y. Fx, as we talked previously, would be f cosine theta, and fy would be f, the magnitude of f sine theta. Force F is a vector, but its component in Cartesian form, fx and fy, are not vectors, they are scalars. So what's the significance for us that they are scalars? When you have multiple vectors, if you're dealing with the scalars, you can just simply add the components together because they are scalars. Addition of a scalar is pretty simple. If you have a component 2 Newton and then 5 Newton and 6 Newton, you can just simply add them together. And that's why we are interested in converting every vector into its component form in Cartesian form, so we could add or subtract them easily. So let's say you want to find a resultant force. Let me draw my coordinate system. I have a coordinate system here, and I have 3 vectors of force. F1, call this F2, and another vector here, F3. And if I want to find the resultant vector, FR, or sometimes it's called R, it's a resultant force. It's the addition of all forces. In many problems, the question is asking you to find the resultant force, F1, F2, F3. So instead of dealing with triangular or parallelogram rules, we are going to use Cartesian form to add these vectors together. So my first task is to find the component. F1, the component in x direction, would be this component F1 here. I call it F1x. Then I want to find the y component as well. That would be F1y. Same thing for F2, we have F2x, and here I have F2y. For F3, the y component you can see is in the negative direction of y, so we need to pay attention when we are adding the component together. That would be F3y, and this would be F3x. So FR, if I want to find a resultant force, because I'm dealing with component now, we can just simply add them together. So I have one component of F1x here, that's x, F1, F2x, and F3x. These are all a scalar, so I can simply add them together, add the magnitude together. So I can say FR would be F1x plus F2x. F3 is in the negative direction, so that component should be negative. That's why the negative sign appears here. And the unit vector in x direction would be I. Similarly for the y direction, I have F2y, F1y, and F3y. These two are in positive y, and F3 is in the negative y. So I add F1y plus F2y minus F3y, and the unit vector is j. The unit vector tells me the direction of these components. So this, the total would be the x component of our resultant force. Is usually denoted by FRX. And this one would be FRY. So the resultant force, now I can write it in form of Cartesian. FRXI plus FRYJ. So I have two components. I can find a magnitude and the angle for these. What would be the magnitude of FR if I have the components? The two components are perpendicular to each other. So we can use Pythagorean theorem to find the magnitude. So a square root of the first component squared plus a square root of the second component. And the angle would be tangent inverse or arctangent of FRY over FRX. So and that angle, this theta, is the angle between the positive in the positive x direction. So here, if you have FR, the angle from positive x to our vector. This is FRY, this is FRX. If you want to find the angle, that would be tangent inverse or arctangent of FRY over FRX. So we can represent vector FR in two ways. One, in its Cartesian form, FRX and FRY, so we need two values to represent it, or in terms of magnitude and the angle. Sometimes the question specifically asks you how you need to find or determine the vector, whether in Cartesian form or magnitude and angle. Let's look at this problem. Determine the magnitude of the resultant force and its direction. So the problem is asking for the magnitude and direction. So we need to find the resultant force and its direction. Resultant force FR. Let's go back to black. So FR would be F1 plus F2. But these are vectors, so I can simply add them together. I need to change them into its Cartesian form. F1, Cartesian form, it has a component in x, that's positive x. It has a component in y, positive y. So F would be 200. What would be the x component? I don't have the angle here. I don't have the adjacent angle. I have the angle here, 45. So that would be sine 45 here for me. I'm dealing with 45 degrees, so sine and cosine would be the same, but the concept is that you need to use the adjacent angle for cosine and the opposite angle for sine. And y component is also positive, so 200 cosine 45. I know cosine 45 is the square root of 2 over 2. So I can simplify that. F1 would be 100 square root of 2i plus 100 square root of 2j. And the unit system that I have is Newton. And let me write I and j here as well to be consistent. So I'm done with F1. I wrote it in Cartesian form. Now I need to move to F2. Let me use another color for F2. Here it has two components in the x direction. You can see the component in x direction would be the opposite direction of x, and has one component in y. The component in y would be positive, or positive y. So that's very important to note. F2, what is the magnitude? 150. I'm talking about the x direction, which is negative. So negative 150 cosine 30 plus 150 sine 30. That's the I, and that's the j component. So the x component was towards negative x when I write the component, and the y component was positive y. That's why I use negative here and positive over there. So I can simplify that. F2 Cosine 30 would be a square root of 3 over 2. So that would be negative 75, a square root of 3i. And sine 30 would be 0.5 or half. So that would be 75j. Let me write the unit. Make sure to write the unit all the time. So if I want to add the vectors together, f1 and f2, now I wrote my vectors in Cartesian component. So I can just add the component. I have x here and here. I add these two together and I add these two together. And they are in the same direction. I and I, j and j. So that makes it easy for me. fr would be 100 square root of 2 minus 75 square root of 3i, and the j component would be 100 square root of 2 plus 75 j. Unit Newton. I put all of them in bracket and then Newton. You always need to write the unit system. Even if I forget it, that doesn't mean it's right. You have to include the unit. So the magnitude would be here 11.2 I, and here would be 271.3 j Newton. So I found it in Cartesian form, but the question is asking for the magnitude and angle. So magnitude, Pythagorean theorem again. 11.52 squared plus 271.3 squared. The answer, 271.6 unit Newton. Angle, tangent inverse of the y component over x component. What is the y component? 271.3. X component 11.2. The angle should be sharp, so it's 87.57 degree. Well, the y component is much higher than the x component, so when your vector will look like something like this in x and y coordinate system, because the y component is much higher than x. That's why I said that the angle should be very sharp here, which we found a sharp angle to 87.757 degrees. So we found the two unknown that the question was asking for, the magnitude and also the angle. Let's solve another problem for 2D Cartesian. Determine the magnitude of the resultant force and its direction, measured clockwise from the positive x-axis. That's how we report the angle. So here in this problem we have 3 forces rather than 2 forces, but the procedure is the same. At the end, when you want to find forces, Fr would be F1 plus F2 plus F3. For this force, it's in positive x direction, so that makes it easy. These 2 forces, we don't have the angle, but we have this triangular dimension. Let's see what that means. First, I'm going to explain this triangle that we use instead of angle. 3, 4, 5 triangle. Let's say this angle is theta. You can find this angle because you have the dimensions, but you don't need to find the angle and use like arctangent or cosine inverse to find the angle. We can use this dimension in our calculation. What is cosine theta? Cosine theta is 3 over 5. What is sine theta here? It's 4 over 5. So whenever we need cosine theta, we are going to use 3 over 5. Whenever you need sine theta, we are going to use 4 over 5. Or cosine theta, you can think of it as the horizontal component. Whenever we want to find the horizontal component, we are going to use 3 over 5. If you want to find the vertical component, we are going to use 4 over 5. So that's what these triangles are for. Sometimes instead of reporting the angle, we are reporting the corresponding triangle. So now we have 3 forces. We are going to find the component of each force and add them together. If we convert everything to Cartesian form, then adding would be a scalar addition. So I'm gonna write everything at once here. So FR, I'm gonna add all the x component. X component here, this vector, all of it is x, 30. Then I have 40 here, my vector 40. I need the x component, so 3 over 5. 40 cosine theta, you can think of it would be 40 times 3 over 5. So 40, instead of writing cosine theta here, I just write 3 over 5. Because I said cosine 30 is equal to 3.5 here. And then here I want to find this force. I'm interested in x component or the horizontal component, so that would be 5 over 30 based on the same logic that we used here. So, and it's negative. I mean the x component is positive here. The y component would be negative. So the magnitude is 91. I'm interested in the horizontal component of 5 over 30. And that would be my I. I will do the same thing for the j, plus. This force doesn't have any component in y. It's just in x direction. This force has these two forces are going to have a component. This component will be positive, and this force is going to have a negative component. So let's just start with 40. It's positive vertical component, or sine theta, or 4 over 5. So 40 times 4 over 5. This component is going to create a negative value in the negative direction of y. So, and then I'm interested in the vertical component. So 12 over 13. J. So FR, if I simplify that, would be 89I negative 52 J. What's the unit? Here is not Newton, it's pound. Pay attention, just don't write Newton randomly each time you're talking about force. Look at the question, it's pound, pound. Sometimes you have Newton and kilonewton mixed, so you need to just pay attention to that one as well. So we want to find the magnitude, Pythagorean theorem, square root of 18 squared, plus, then we are talking about the magnitude, the negative doesn't matter, but I'm just going to write it here for you. 103.1 pound. Now we're going to find the angle, tangent inverse, the y component 52 over the x component 89, to the 30 degree. So here the question was asking for clockwise. Let's talk about the angle a little bit here. So if you have x and y here, then the y component is negative and the x component is positive. So it means that our vector, resultant vector, is somewhere here. It has a negative component of y, it has a positive component of x. If I just write the symbols here, tangent inverse of 52, this is 52, and here would be 89. I find this angle, theta, 52, 89, clockwise from the positive x-axis. So the question is that what if we use negative 52 here? Then you find the larger angle, you find this angle. So as long as you show it what angle you're talking about, then it's okay what method you're going to use. Either use the positive values, and that means clockwise, or use the actual negative value, and that means that counterclockwise from positive x-axis. So that's the difference between how you're going to present your angle.